So we're getting ready to start mechanical energy. Mechanical energy is the movement of machine parts. Mechanical energy comes from the motion of kinetic energy and the position of objects, or potential energy. So some examples are wind-up toys, grandfather clocks, and pogo sticks. Wind power also uses mechanical energy to help create electricity. Our equation for mechanical energy is pretty easy. It's potential energy plus kinetic energy is mechanical energy. And the shortcut version is PE plus KE equals ME. These problems are super easy because adding and subtracting, right? Now, they are a little more thought-provoking. You have to think through them, but once you get it, the math is really easy. So remember that law of conservation of energy we talked about earlier in the year? It just says that energy cannot be created or destroyed. So that means the total mechanical energy at the beginning is the same as the kinetic energy at the end. So if we take a look at this picture, say we picture a swing. So maybe the top here is going to be the top of the swing. So this is the highest point you can possibly go. The total mechanical energy is constant. So we have a really high potential energy and a really low kinetic energy because we are not moving. Then as we go down, our kinetic energy is increasing and our potential energy is decreasing. And then we get faster and faster, our kinetic energy is increasing. As we go back up, our potential energy will increase and our kinetic energy will decrease. And then if we get up here to the top part again, we have a high potential energy and a low kinetic energy. So if we combine those two concepts, mechanical energy and the law of conservation of energy, we have mechanical energy at the beginning is equal to mechanical energy at the end. So we could say that the potential energy plus the kinetic energy at the beginning equals the potential energy plus the kinetic energy at the end. So let's do an example problem. Okay, so let's take a look at this diagram. So at the start of our skateboarder, he has all the potential energy. He's not moving. Okay, so let's say he has 10 joules of energy. And that's all potential. He has no kinetic energy because he's not moving yet. He starts down the hill. He gets to the bottom. Okay, so his height is 0. He has 10 joules of kinetic energy now and no potential. He gets up there almost to the top. So not quite to the top, but almost. So let's say he has 9 potential and 1 kinetic now. Goes back to down to the bottom, up to the top. So now he's at point D. So he's halfway exactly. So he has 5 potential and 5 kinetic. Now he's at the other side, and so he's almost halfway. He's got 4 potential and 6 kinetic. So it's kind of like a seesaw. So how much ever potential and kinetic he has, it's going to be always 10 and then some variation thereof. Okay, so mechanical energy is conserved.